Mango Math presents Indy 500, a pre-algebra game. Indy 500 falls under the math strand there where students will use variables to represent two quantities in a real-world problem that changes in relationship to one another. Compare the two proportional relationships. Indy 500 has some math terms to help increase understanding, and that's the distance equation. D equals RT, where D stands for the distance, R stands for the constant or average rate of speed, and T stands for time. We also have rate is the ratio that compares quantities measured in different units. The supplies that are provided in the pouch along with your information sheet and guide will be a Indy graph chart, a timer, a little push car or friction car, dry erase marker and eraser, and a measuring tape. So the students will start with their graphing chart, and they will have their little race car, and they first got to decide what type of trial they're going to have. What are they measuring? What do they want to determine? So in this one, we're going to determine how far does the car go from start to stop, and how fast does it go? So we're going to let the car just go all the way until it runs out of steam. So we're going to have our timer, and we're going to time the distance, or time the amount of time it takes for the car to start and go until it runs out of steam. And then we're going to write that time down. So car 1 is 22 and 35 hundredths of a second. The second car was 25 and 6/10 of a second. And then we're going to measure what the distance is. First car was 26 and 3/4 of an inch, and the second car was 29 and 1/2 of an inch. So now we're going to try to figure out the rate. So what is the rate? How far did the car go per second? So we're going to use the formula for distance, which is distance equals rate times time, or D equals RT. We have our distance, which is 29 and 75 hundredths, because 3/4 is equal to 0.75, is equal to the rate, which we don't know at this time, but we do know the time, so we don't know the rate, but we do know the time. So we'll put that in there. We'll do the mathematics. We have to divide 22 and 35 hundredths from both sides, and that will give us the rate. So our rate is 1 and 2/10 of a second equals our rate. So we'll write that down. The rate of the second car, we'll do the mathematics on that, and we get 1 and 15 hundredths equals the inch per second, and we will put that down. So from there, we are going to do 3 trials to get an average amount. So we're going to do the trials. We're going to put down all the information that we've measured, and we're then going to total up each column and divide it by the amount by 3 to get our mean or our average. So we are going to do the mathematics on all of those, and we come up with what our distance, average distance, and average time was, and then we can come up with from there what was how many inches did we go per second. So with our graphing chart, we do have 3 different trials that we can do, or 3 different tests that we can take, and each one we need to kind of determine what it is that we want to do for each one, so that they're different and we're testing different things. So the first test, we did the speed to a specific point. We could do types of winds, like the wind-up car. Do we wind it really tight? Do we just pull it back once? How do we want to do it? You can put in ramps to see if going uphill is going to have a different. We can also do down ramp. We could also do the speed. I have on the first one I missed was the speed to a specific point. So you can say, I'm going to measure from this spot to this spot only. If a car goes past that, that's fine. But that's when we talked about consistent speed. At what point can we get a good idea of a consistent speed of that wind-up toy if it wasn't wound up? So having different things that you can test with those cars. Some guided questions to promote critical thinking. How much time would it take the car to travel the length of a football field, which is 100 yards, if it maintained the constant rate of speed? So that's that constant rate of speed we were trying to determine between those two specific points. And we can change it to meters and say what if it was going around like a track on a football field, which is 400 meters. In what distance would the car travel if it ran for 10 minutes and ran for 30 minutes? So if you had your car running at a consistent speed, how far would it go in 10 minutes? How far would it go in 30 minutes? So some great questions to kind of do some scientific experimenting with numbers and using the data to help you. So it's a great activity to get that science-math connection.